What's up, everybody? It's Dan from Sage Math Tutoring, and back with another video. This is a video where I cover some problems from a practice test for a state test for 7th grade. I have a student who is definitely good at math. However, it would be probably helpful to just have a little refresher on some of these concepts. So let's take a look. Problem number 7, one apple costs 55 cents. At the grocery store, customers receive one free apple for every 8 apples that they buy. Anna paid a total of $8.80 for her apples. How many free apples did Anna receive? So again, for every 8 apples this person buys, they're going to get one free apple, and each apple is 55 cents, and they paid a total of 8.80. So let's find out how many apples this person paid for, right? I think my student watching would recognize that that would be a matter of just dividing $8.80 by 55 cents, right? And to do that, you could always move that decimal over 2 times, right? Because we don't want this number to have a decimal in it. It's okay for this number to have a decimal in it, but we don't want this number to have a decimal in it. So if you were to perform that, it would be this. 55 goes into 88 once, right? So we have that, subtracting and then dropping that down. And 55 goes into 336 times, I think, evenly. So that should work. Would that work? Yes, that would work. Okay, so this person, Anna, bought 16 apples. That's just the fact. And for every 8 apples, Anna gets a free apple. So, of course, that is going to be 2 free apples, right? So if this person bought 16 apples, well, that's 2 blocks of 8 apples, right? 2 blocks of 8 apples, and there's 1 free apple for each of those, right? So that's 2 free apples. Okay, so I guess the way to enter that, I don't know. I would put it there, maybe. Okay, so that's that. Looking at the next one. Problem number 8. Okay, looks like we're allowed to use a calculator here. That's great. A dance studio offers ballet and hip hop classes. The studio has 8 ballet classes. For every 12 hip hop classes, how many hip hop classes are there for each ballet class? Well, let's see. Hip hop to ballet. Okay. So for my student watching, I would just recognize that we're trying to compare hip hop classes to ballet classes, right? And I would put the hip hop on top. I'll keep it in green. Hip hop is going to go on top. I'm basically going to set up like a proportion, I think. So, and then hip hop goes on top, ballet on the bottom. And we know that there are 12 hip hop classes that correspond with 8 ballet classes, right? So that is going to be 12 hip hop classes for every 8 ballet classes. And this is sort of an interesting question. How many hip hop classes are there for each ballet class? Now, the word each implies that we want to think of only one ballet class. So, what we could do is we could set this equal to another fraction where we kind of force the ballet classes to be 1 down here. Okay. And then we're wondering, what would this be right here? Okay, this number. So what I've done for my student watching is I've set up what's called a proportion, where I took the original relationship that they had mentioned, which is 12 of these for every 8 of these. And I made sure I'm keeping hip hop on top for now. So it's 12 over 8. And I'm comparing it to some other fraction where we are analyzing each ballet class. So that means there's only going to be one down here. And we need to find out what this number is. Now, for my student watching, you did sort of a trick yesterday where you did a thing where you were like, okay, well, 8 divided by 8 would give you 1. So maybe 12 divided by 8 would give us this number. And that's actually true. Um, so, you know what? I actually don't mind that method if you want to stick with that. So, it is the case that to get from 8 to 1, you could divide by 8. So then we could say, okay, well, what's 12 divided by 8, right? And that's going to give us this number. The only thing is, that's going to be kind of like a weird situation. But the good news is this is a calculator problem, I guess, right? So you could literally just do 12 divided by 8 in your calculator, and that would be 1.5. Okay. Now that is the answer, actually. Okay. It's kind of a weird thing to be like, there's 1.5 hip hop classes for each ballet class, but that's what they're asking. You just have to kind of go with it, right? So for every ballet class, there is 1.5 hip hop classes. Okay. So that is the answer to that one, and you would fill it in here. So I guess that would be 1.5, like that. So that's how you do that one. Let's take a look at this. Rafi has $48 to spend on games. Each game costs $3. He writes the expression shown to represent the amount of money he has after purchasing G games. Okay. So this represents the amount of money he has after purchasing G games. I'll even write that. So this is the amount of money he has after purchasing G games. And then this person wrote an equivalent expression as shown. So this is nothing more than having factored out a 3 from the above expression, which leaves you with 16 minus G. Now, let's see. We could also turn that into an equation as well, right? It's kind of the same thing. What does the number 16 represent? Right here. Well, that might not be obvious upon like analyzing this whole thing. It might be a good idea to inspect each answer choice though and find out which answer choice kind of works after thinking about it. So let's take a look at answer choice A, the total number of games Rafi can buy. Well, it is true that if this person purchases 16 games, well, then this G right here would be 16. And then it would be 16 minus 16, which is 0. And then it would be 3 times 0, which is 0. So after purchasing 16 games, the amount of money this person would have left over would be 0. So that actually makes sense with regards to answer choice A. The total number of games Rafi can buy is indeed 16, because if this G right here was 16, then this person would have $0 left over. So that actually is the answer. Now, if we want to inspect the other answer choices, that's not a bad idea. Is it the case that 16 represents 1/3 of the number of games Rafi can buy? Well, no, we already sort of discussed how 16 is the number of games that Rafi can buy. So answer choice B is clearly wrong. Answer choice C, the amount of money Rafi has after buying G games. Well, that's not clear, the amount of money that Rafi will have after buying G games. We don't know that. This is an expression that represents the situation of, how much money he would have after buying G games. But we have no reason to believe that this person would have 16 after buying G Games, partly because we don't know how many games G Games is. Okay, so that's wrong. Looking at answer choice D, the amount of money Rafi has after buying 3 games. Well, one thing you could do is you could always plug 3 in for G and see what happens. 16 minus 3 is 13, and then it would be 3 times 13, and that would be 39. So the amount of money Rafi would have after buying 3 games would be $39. That is not $16. So answer choice D is gone. Okay, the box plot shows a comparison of the heights of gymnasts and basketball players. The mean absolute deviation for each group is approximately 2. How many mean absolute deviations describe the difference between the 2 medians? Well, of course, there might be sort of a temptation to work with mean absolute deviation, which is sort of its own concept. That's something that I will discuss perhaps later in this video if it comes up again and if we need to discuss it. This, in a sense, is sort of a trick problem or a trick question because the reality is they kind of are nice enough to give you the mean absolute deviation of the situation, which is 2. Okay, so that's the mean absolute deviation for both groups. Okay, it's 2, approximately 2. And then they want to know how many of those describe the difference between the 2 medians. Well, when they say the difference between the 2 medians, that means that you're taking one median and then you're subtracting the other median because that's what the phrase the difference means, right? You are subtracting one median from the other. So then the question is, what's the median of the first group? And then what's the median of the second group? And then once we figure that out, we can subtract maybe the smaller median from the larger median. Well, this kind of challenges us to remember what a box plot means, what a box plot is communicating. So this is indeed a box plot for gymnasts, and this is a box plot for basketball players. So for my student watching, you should understand that there's sort of like, a fair amount of communication, a fair amount of things being communicated by each of these. But there's one very important thing that's being communicated by each box plot. One thing that's being communicated with this box plot is that the median is right here, which kind of corresponds to I don't know, just under 60, right? And the median for this box plot is right here, which corresponds to 75. So the median of this group here, I'll even write it, median is, we'll call it 60. And the median here is 75, right? So again, if we want to find the difference between the 2 medians, my student watching, of course, understands that will be nothing more than subtracting 60 from 75. Okay. Now, does my 60 look like a 50? It shouldn't. It should not. That should be a 60. Well, of course, 75 minus 60 is 15. But we don't want to make the mistake of saying, oh, the difference between the medians is 15, and then just write that as the answer. Some students might do that. However, for my student watching, hopefully you're catching the fact that the question is asking how many mean absolute deviations are sort of between these, right? Well, each mean absolute deviation is 2, right? So what we would have to do is find out, well, how many blocks of 2 are between these 2 numbers, right? Hopefully my student watching understands that will be nothing more than taking that 15 and dividing it by 2. So 15 divided by 2 would be, 7 because of 14, right? And then remainder would be 1. But then if we wanted to not use a remainder, but rather use a decimal, my student watching probably recognizes we would drop the 0 down, and then we would have a 7.5. So that should be the answer there. with regards to how to answer the question, perhaps in a way that the test makers would appreciate. I think to just sort of have all of this work here perhaps represented in this. Okay. So that is how to do that one. Let's see. Gary is thinking of three numbers, A, B, and C, where B minus A equals C, and C happens to be less than 0. Select all of the number lines that could represent Gary's numbers. Okay. Yeah, so tricky, definitely tricky. They're giving us two pieces of information that are both important. The first is the yellow information, and the other is the green information. Now, let's focus on the green information. This is saying that C is less than 0, which means that C is a negative number, okay? That means that this C right here is a negative number. Now, that could only happen if B was less than A. So if B is some small number and B is subtracting a larger number, hopefully my student watching agrees that C would end up negative. So we know for a fact that A as a number, right, whatever A is larger than B. Okay. So A is definitely larger than B. And one way of saying that is that, another way of saying that rather, is that A is to the right of B on the number line. Okay. Isn't that what's sort of implied by the fact that A is larger than B? If A is larger than B as a number, then A has to be to the right of B on the number line. So we want to circle all the answer choices that feature A being on the right. So clearly this one is gone. This would work. This would work. This would work. This would not work. And this would work. So let's see. Do I agree with that? Yes, I do. So that's how you do that one. Dana walks 3/4 of a mile in 1/4 of an hour. What is Dana's walking rate in miles per hour? I think the smartest way of going about that one is to recognize that when they say miles per hour, that is to put the word miles above the word hour. Okay. So for my student watching, just know that miles per hour, another way of thinking about that is miles over hours. And I'll even make that plural. Okay. Now, that is kind of helpful framing because we could sort of immediately just say, okay, well, for every 3/4 miles, right, you're going to have 1/4 hours, 1/4 hours. Okay. You can just kind of immediately take advantage of this relationship that they're already telling us is true by saying, oh, this goes with that. Now, they typically do not, in a sense, this is the miles per hour speed. It's, you could think of it as the following, actually. You could think of it as 3/4 over 1/4 miles per hour. Okay. In a way, we almost like already have the answer. Like it's this number, miles per hour, right? But this is not a nice looking number. So obviously in this answer, grid, they're not going to want this, right? They're going to want you to turn that into like a nice number. All right. Now, I'd like to analyze this over here. My student watching I think, recognizes that it's really 3 over 4 divided by 1 over 4. Now, there is sort of a shortcut that people will learn over time where when you have a little miniature denominator over another fraction that has a miniature denominator, these denominators would cancel. Okay. And then you'd just be left with 3 over 1. However, for my student watching, I think I want to remind you that anytime you have a fraction over another fraction, well, that's really the top fraction divided by the bottom fraction. And for my student watching, I think you understand that that could be rewritten or thought of as 3/4 divided by 1/4, right? I mean, that's really what the red thing is saying. And then hopefully you remember that this is a keep, change, flip situation. So you keep the first fraction, you change that division into multiplication. I'm going to use an asterisk for that. And then you flip the second fraction, which of course is 4 over 1. Now, really, two ways of going about this. One way of going about it is the sort of advanced way, and that is to recognize that when multiplying fractions, you can do this sort of diagonal cancellation thing. So, for example, since this 4 is diagonally positioned from this 4, you could actually cancel those where that turns into a 1, that turns into a 1, and then it would be 3 times 1 across the top, which is just 3, and then 1 times 1 across the bottom, which is just 1, and then you could realize that's just, 3, right? Uh, but let's say you forgot that. Let's say that you forgot that you could do that kind of a cancellation. It's really not the end of the world because when it comes to multiplying fractions, it's quite easy. You just multiply across the top and across the bottom. So 3 times 4 across the top is 12. 4 times 1 across the bottom is 4. And then you look at it and you ask yourself, okay, could I go further with that? And the answer is yes, because 12 over 4 is the same as 12 divided by 4, and that is the same as 3. So the answer to this one is 3. Okay. So in other words, it's 3 miles per hour. Okay, this number turns into a 3, right? After kind of going through this whole process, it turns out to be 3 miles per hour. Okay, looking at problem number 13, a fair cube, in other words, just a regular cube, has 2 blue sides, 2 red sides, 2 green sides. What is the probability of rolling a blue or red side? Um, so the word or suggests that you will be adding the probability of rolling a blue side plus the probability of rolling a red side. Now, when you get into higher level probability type questions, it becomes a little bit more nuanced. However, for this situation, hopefully we can all agree that it's not possible to roll a blue side and a red side at the same time. If you're rolling a blue side, well, it therefore means that you didn't roll a red side and vice versa. So that's actually important to recognize, okay, even though that seems obvious. Now, it is the case that probability, generally speaking, is always the desired outcome over possible outcomes. I've always found it to be a little easier to immediately just kind of know what the possible outcomes are, the number of possible outcomes are. In this case, hopefully, we all agree that if you have a cube, well, a cube has 6 sides. You can think of like a dice, right? Well, one of those 6 faces will land up. So therefore, there are 6 possibilities, right? So when it comes to the probability of rolling a blue side up, you could think of that as definitely 6 possibilities on the bottom, but how many possibilities should there be in the numerator? Well, how many ways can blue land face up? Well, since there are 2 blue sides, that's going to be 2. Okay. And when it comes to the probability of rolling a red side, my student watching, I think, understands, well, that will be the same number on the bottom because how many possible outcomes are there? Well, there's six possible outcomes, right? And of those six, how many of those include the red? And I think my student watching understands that that will also be two. But once again, since they're using the word or, that implies that you're going to add this probability to that probability. And you can go ahead and just do that. For my student watching, hopefully you remember that when you're adding fractions, you want there to be a common denominator. In other words, you want the denominators to be the same. Well, that is the case here. The denominators are already the same. And when the denominators are the same and you're adding fractions, you actually keep the denominator as it is. You leave it alone, but you do, of course, add the numerators. So 2 plus 2 is 4. And then you could ask yourself, okay, can 4 over 6 simplify? Well, the answer is yes, because this 4 is divisible by 2. It's also the case that this 6 is divisible by 2. And then that's going to be a 2 over 3. Okay, so the answer is 2/3. Maybe they would want you to kind of have all of that work shown. Okay, so that's that. Okay, Angela drew the two rectangles shown. The second is a scale drawing of the first. Got it. Okay, so this is the first one. And it's as though this rectangle kind of got blown up to this larger version of what used to be this one. What scale factor did Angela use to draw the second triangle? So, scale factor is kind of an interesting concept. Um, and let's remind ourselves that the scale factor will always be, we could say, the new thing, the new measure, all over the old measure. Now, what do I mean by that? Hopefully, my student watching recognizes that, you know, this red thing is 4.5, and that kind of corresponds with this red thing. You know, it's this sort of shorter side. Like you see how this side is the longer side of the rectangle? This is the shorter side of this rectangle. Well, this is the shorter side of this rectangle, right? Because this is longer. So it's as though you had this first rectangle and then it got scaled upwards and became this bigger version of itself. Well, my student watching hopefully recognizes that this short side sort of blew up and became this side. You know, it expanded, right? So I'm going to refer to this as the new measure, right? It used to be this, but then it became this, and that's the new measure, whereas this is the old measure. So you could then be like, okay, well, it's going to be 11.25 because that's the new measure all over the old measure, which is 4.5. Now, unfortunately, even though in a sense this is kind of sort of the answer, right? This is all clunky looking. They're not going to want, there's no good way of entering this answer into the grid. So you have to actually like figure out what this is. And really, the best way to do that, um, hmm, yeah, the best way to do that, in my opinion, is to treat this like a division problem where it's really 11.25 divided by 4.5. Now, the good news is that this is, I guess, a calculator problem where you could literally put 11.25 into your calculator and then divide it by 4.5. Now, when you do that, it turns into 2.5. Okay, so that is going to be the answer for that one. Okay, the tables show the cost for different numbers of song downloads. Which table shows a proportional relationship? Okay, so the best way to know whether or not a table is giving you a proportional relationship is to take the number that's on the right and divide it by the number that's on the left, and then just double check and see if you end up with the same result every time you do that. in the same table. Now, what do I mean by that? What I mean is you would take 350 divided by 2, and then you're going to get some number. And then you take 7 and divide it by 4, and you see if you get the same number. And then you would take 875 and divide it by 5, and then you see if you get the same number. And same with this. Okay. Uh, and if it's the case that every time you do that, you end up getting the same number, then yes, the table is depicting a proportional relationship. So 350 divided by 2, let's take a look. So that would be 1, right? And then that's a 2, and then we have 1, 15, and that would be a 7, and I think that's a 5, $1.75, right? And then if you did 7 divided by 4, let's take a look at that. We'll use decimals like that. We'll put a decimal up here. So 4 goes into 7 how many times? Once. And then you would subtract and then drop that down. Then that would be this, right? You'd have a 28, and then you would drop that down, and that also would be $1.75. So it's actually looking really good right now, right? So let's try the next one, which is 875 divided by 5. 8 goes in, or 5 goes into 8 once, and dropping this down, this would be a 7, and then hopefully my student watching agrees that it would be this. And then we would have that. So again, so far so good. Let's check that last row. That's 1325 divided by 7. 7 goes into 13 how many times? That would be 1. And then, this 13 minus 7 is 6. And then drop that down. 7 goes into 62 how many times without going over? So that's going to be 8. So already, unfortunately, this is gone, right? So it's kind of mean of them to give us an answer choice where it's only because of the last one it didn't work. So let's now look at answer choice B, right? 350 divided by 2. Well, we already kind of discovered that that's $1.75. And we also discovered that 7 divided by 4 is $1.75, but $8 divided by 4 is $2. So already that's gone also. So we know that answer choice A is gone, answer choice B is gone. Okay, we know that $3.50 divided by 2 is 175, and this is going to be $2. So that's gone. So by process of elimination, we know that answer choice D is the answer, and it must be because this $12.25, when you divide that by 7, you will indeed get $1.75, because this last row is the only thing that's different about this table when you compare it to this table, right? Everything's the same for the first 3 rows. It's only that last row that's different. So answer choice D, by process of elimination, would be, the answer. Okay, Raquel is building a shelf for her wall. The length of the wall is 11 feet 3 inches. The shelf will be built on the center of the wall, and the length of the shelf will be 1/3 the length of the wall. What is the distance in inches from the edge of the wall to the edge of the shelf? Well, I think that a picture would be good. Let's imagine that this right here is the wall, okay? And we know that it's 11 feet 3 inches. So I'll write 11. I think it's just one of these, right? 3 inches. Now, it's the case that the shelf will be built in the center of the wall, and the length of the shelf will be 1/3 the length of the wall. So it's almost as though you almost like divided the length of the wall into 3 equal pieces, right? And that shelf would be like in the middle piece. Okay, hopefully that makes sense, right? because once again, the length of the shelf is 1/3 the length of the wall. So again, dividing the length of the wall into three equal pieces, and the shelf would be equal to the length of one of those pieces. And not only that, it's positioned in the middle. Okay. So then they want to know what's the distance in inches from the edge of the wall to the edge of the shelf. So, in other words, they want to know what is this distance right here? What is this distance? Well, isn't that distance just 1/3 of this whole length? It is, right? So, why don't we just, find out what is this length in inches, right? Because it's 11 feet, 3 inches. What is this whole length in inches? And then we'll just divide it by three. And that should be the answer because they want the answer in inches. Hopefully that's clear. Well, how would you convert 11 feet, 3 inches into inches? Well, we could recognize that there are 12 inches in 1 foot. So if we have 11 feet, obviously that's going to be 11 times 12. And you could even use your calculator for that. 11 times 12 is 132 inches. But then we have to remember that it's not just 11 feet long, it's 11 feet and 3 extra inches after that, right? So you would have to add those extra 3 inches. Hopefully, we acknowledge that that would be 135 total inches. And once again, we are going to acknowledge, sure, that the entire length of the wall is 135 inches. However, it's the case that we want to divide that by three. And when you divide 135 by three, you get 45. So that is 45 inches away from the edge of the wall. Okay. That's how, wide these sections are. Okay. And for the record, the shelf itself must also therefore be 45 inches. And this side must be 45 inches. So hopefully that makes sense. Which pair of data sets provides no evidence that the values of set A are greater than the values of set B? Okay, so interesting. These are the other answers. So I think the most important thing with this is to sort of understand what these like dot plots are communicating. All right. So for my student watching, let's only look at answer choice A and analyze what this is communicating. First of all, a set is nothing more than just a list of numbers, particular numbers, right? So we have a particular list of numbers here, and we have a particular list of numbers here. What's being communicated with the dot plot for set A is that if you were to list all of the numbers out, separated by commas, maybe even from least to greatest, apparently there is only one four in that list. There are three fives in that list, and there is one six in that list. So what would that list look like? It would look like four, five, 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 and then six. Looking at set B, I think my student watching understands. There is one, there's 1 2 in the list. There's only 1 3 in this list. There's 1 4 in this list, and there's 1 5. So that set would look like 1 2 3 4 and 5. Okay. Now, that is how to sort of read and understand these dot plots. Now, it's the case that it's asking which pair of data sets provides no evidence that the values of set A are greater than the values of set B? Well, we can clearly see that some of the values in set A are indeed greater than the values in set B. For example, there's a 6 in set A, and that's greater than the values here. So that's what you need to keep in mind when analyzing the answer choices. Now, hopefully, it's clear that if you were to list the numbers in set A for this answer choice, well, there'd be a six in that list. There's no six in this list. The highest number in this list would be a four. So, therefore, answer choice B is not the answer. Okay, so once again, let's remind ourselves we want to find out which pair of data sets provides no evidence that the values of set A are greater than the values of set B. Well, there's plenty of evidence that the values of set A are indeed greater than the values of set B because there's a six in value set in set A. With regards to answer choice C, I think, or yeah, we can see clearly that there are values in set A that are greater than the values in set B, and therefore my student watching probably understands that answer choice D is clearly the answer. Now, the highest value listed in set A is 4, and the highest value listed in set B is also a 4. So there's just no evidence that there are any values in set A that are more than the values in set B. Now, it could be the case that this goes on forever and there are some values in set A, like over here, but there's just no evidence given the picture. Okay, so that is problem number 17. Let's see. Problem number 18. The circumference of a circle is that. What is the diameter of the circle to the nearest inch? So hopefully we are remembering that the circumference of a circle is kind of like the distance all the way around a circle, and there is a very specific formula for that, and that is that the circumference is equal to 2 times pi times the radius r. And let's remind ourselves that the radius is the distance between the center and the edge, so that would be the radius. Hopefully, we are also remembering that the diameter of a circle, which is what they're asking for, is this entire distance from one point on the edge to another point on the edge in such a way that passes through the center. Now, hopefully, my student watching recognizes that the diameter is therefore nothing more than 2 times the radius, right? It's this total length here, and that's clearly this radius plus this radius, and that would give you the diameter. So therefore, we know that the diameter, I'll call it D, is equal to 2r. Okay. And if you think about it, that 2r is here, right? Therefore, we could sort of rewrite the formula for the circumference of a circle to be 2 times r times pi, because you could indeed rearrange all of this. Now, for my student watching, you don't have to write all of this. I'm only writing these things down so that you understand the general idea. Okay. Once you understand the general idea, hopefully, sort of the path to the answer will just kind of come to you based off of understanding the ideas involved, right? Now, the idea here is that, yes, the formula for circumference could indeed be written as 2 pi r, but another way of writing the formula for the circumference of a circle is that it's the diameter times pi, okay? Because 2r is the diameter. So we really have two equally valid ways of writing the formula for the circumference of a circle. You have the red box way and you have the blue box way, and both are equally valid. Okay? Now, let's remind ourselves of what we're even doing. They say the circumference of a circle is that. What's the diameter of that circle? Well, I feel like the blue box version of the circumference formula would be more helpful to us because it kind of features the diameter already. Now, they said that the circumference is already 18.84, right? So couldn't we just kind of rewrite this to say that, right? We could just say, oh, well, the circumference is 18.84, right? They told us that, you know? And therefore, we can see that this circumference was the result of taking whatever the diameter is and then multiplying it by pi. Now, hopefully, my student watching recognizes that pi is just kind of a famous number that's approximately 3.14. Okay. And therefore, we could say that the situation we're dealing with is the following: it's going to be the diameter times 3.14. I'll use parentheses for that. Hopefully, my student watching recognizes that to find this diameter, all you have to do is take this 18.84 and divide it by 3.14. This is a calculator problem, so you could just kind of do that in your calculator. Once again, it would be 18.84 divided by 3.14. And when you throw that in your calculator, you get 6, believe it or not. So that is going to be the answer to that one. Okay, looking at problem number 19. A box is filled with different colored markers. When a marker is chosen randomly from the box, it is likely that the marker will be blue. Okay, that means that there are more blue markers. More than half of the markers are blue, we could say. That's basically what that means. It is likely that the marker is blue. The fact that it's likely, that means that it's over 50% chance that you're going to pick a blue marker. What does that mean? That means that more than half of the markers in the box are blue. Okay. Select all the possible probabilities that a randomly selected marker will be blue. Well, it's got to be more than half, right? Well, 0 is certainly not more than half, right? Because half would be 1 out of every 2 markers are blue, right? But since it's likely, it's more than half of the markers in the box are blue, so it would be more than 1 out of every 2. So 1/3 is less than half, so that's gone. 2/3 is more than half, so that works. 3/4 is more than half, so that works. 3/2 is larger than 1, so that actually makes no sense. So for my student watching, let me just do something really quick. There is a 0 probability, and probability goes from 0 to 1. Okay, anywhere from 0 to 1. Now, if the probability of something happening is 1, that means it's certain. That means that it's even more than a probability. It's certain that something will happen. 0 means there's no chance that something will happen. If something has a probability of 0, that means that there is no chance that it could happen. In other words, we have a word for that. It's called impossible. I'll say that again for my student watching. If a probability is 0, that means it's impossible for that thing to happen. Okay. If the probability of something happening is 0, that means it's impossible. If the probability for something happening is 1, that means it will definitely happen, no matter what. Okay. Now, it's kind of interesting because this should be an answer, I think, because not only is it likely that the marker will be blue, right? If the probability of picking a blue marker is 1, it's like not only likely, but it's certain that you will pick a blue marker. Okay. So I think that should work. Okay. Because they said it's likely that the marker will be blue. Well, the ultimate form of something being likely is if it's certain that it will happen. So that's a little tricky, but I'm going to vote that answer choice C would also work. All right. Now, this one is interesting because if you really look at this, 3/2, if you were to kind of, I don't know, even do division with that, where it's like 3 divided by 2, that's really 1.5. Now, hopefully, my student watching recognizes that that's more than one. But I already mentioned how probability will always only be between 0 and 1. So it actually makes no sense for there to be a probability of 1.5. That's not going to happen. That literally doesn't make sense. Again, because probabilities are always only between 0 and 1. So answer choice F does not work. Okay. So therefore, it's just these. Okay. Problem number 20. A furniture factory makes 250 tables each day. Create an equation that can be used to find the total number of tables made Y after X days. So they're kind of spelling it out for you, which is nice. The total number of tables is Y. And then, X represents the amount of days gone by. So I think my student watching recognizes, I'm sure, that the equation would be something like total tables made. Well, that's going to equal, 250 times however many days have gone by, right? Because apparently the factory makes 250 tables per day each day. So that's 250 tables times however many days have gone by, right? Well, once again, they already told us that the total number of tables, they want us to use the letter Y for that. So I will replace this part with a Y. And they already told us that they want the letter X to represent the amount of days gone by. So that's going to be 250X. So therefore, this should be the answer. Uh, for my student watching, hopefully it's very clear that since 250 is sort of glued to this X, that implies that it's 250 times X. By the way, that's why I keep using asterisks to represent multiplication, because I want to make sure it's very clear that we're no longer using this sort of X to represent multiplication, because X at this level of math is more often than not a variable. And in this case, the variable represents days. So the yellow box is the answer. Problem number 21. Bowling alley charges X dollars per guest and a fixed $50 rental fee for the party. So whenever they talk about a fixed fee, that means that that's going to be a constant rate. Okay, again, a fixed fee will be a constant rate, which means that it's going to be a number that does not have a variable attached to it. So, in other words, there's going to be a 50 in the equation somewhere where it's standalone. It doesn't have a variable attached to it. And the only answer choice that's sort of doing that is answer choice C, where you have this 50 that's all by itself. Now, what's being communicated here is that Y is how much the bowling alley charges, how much the bowling alley is going to cost, we could say, for a particular party. Um, it's X dollars per guest, right? And if you have 9 guests, well, those 9 guests each are going to pay that fee that's per guest, right? X dollars per guest. I'll make that green. X dollars per guest, right? So that's this part right here where it's X dollars per guest. And we know that we're dealing with 9 guests, right? So that's captured in this information. It's 9 guests times X dollars, right? But again, there's this $50 fee that needs to be paid no matter what. It's a fixed rental fee. So therefore, the cost of the party would be this cost represent that is associated with the X dollars per guest plus the $50 that you just have to pay no matter what. Okay, so that's this one. Okay, so a figure is shown. What's the value of m? So they want to know what's this angle. Hmm. Well, for my student watching, hopefully you recognize that really two things. Let's say you have a triangle and there's a particular angle measure here that we'll call A degrees. There's another angle measure here that we will call B degrees. And then finally, there's another angle measure here that we call C degrees. And hopefully my student watching recognizes that when you add all of those angle measures, they're all going to add up to 180. Okay. That's sort of a interesting fact about triangles where when you add all the interior angles, they're going to add up to 180. Okay. So that is a factoid that you need to know. Another thing you need to know in geometry land is anytime you have sort of a line like this, and maybe there's this offshoot, like some other, like a ray that goes off of the line like that. Well, I think my student watching would understand or agree that this is an angle that's being formed by that situation. And then you have another angle that's being formed by that situation. Let's call the green angle x degrees, and let's call the blue angle y degrees. Okay. Now, this is a very famous uh, diagram or a very famous sort of geometric pattern that eventually you become very familiar with, and it's called a linear pair. It's two angles that are right next door to each other in such a way that sort of the non-shared sides of each angle form a straight line, and the shared side of each angle go off of that straight line. Okay. Now, whenever you see this, you need to simply memorize the fact that one of the angles plus the other angle are going to add up to 180. Okay. So that's two angles that are right next door to each other like this, where there's like a straight line right here. When you add them, they're going to add up to 180. Okay, so that's not to be confused with the other concept that we just mentioned, which is when you have a triangle. Notice how there's no triangle here. When you have a triangle, all the inside angles are going to add up to 180. This right here is not a triangle, but this is a different situation where you have an angle next door to another angle, and they're going to add up to 180 also. So this is called a linear pair, and this is the concept where the interior angles of a triangle add up to 180. So both of these concepts are going to become useful because at the end of the day, we're just trying to find this angle M right here, right? And we might not know what to do, but we do know that this right here is a linear pair, right? So we know that whatever this thing is, let's call it a green Y. We might not know much, but we know that when we add that y plus the 126, well, that's going to add up to 180 due to the linear pair, right? So what does y equal? Well, clearly y is equal to 180 minus 126. Well, what is that? That is 54 degrees. So again, we might not know much about this whole diagram, but we do know that that is 54 degrees. So I'm just going to replace this y here with a green 54. Now, if you look over here, well, this angle, this sort of mystery red angle, we could call z, okay, z degrees. And hopefully my student watching recognizes that this is a linear pair also, because you could always sort of, turn this so that you could see here's a straight line, and you have this sort of blue angle right next door to this red angle, right? So that's a linear pair also. And I think my student watching would agree, therefore, that the 112 plus the red z, well, that's going to add up to 180 also. So therefore, The red z would be nothing more than 180 minus that 112, and that's going to be 68. Okay, 68. So what I'll do is I will replace this red z with a 68 right now. And great. And then we can understand, oh, well, there's this other theorem that talks about how when I add this angle plus this angle plus this angle, that's going to add up to 180. So you could actually write that. You could say m plus the red 68, right, plus the green 54. Well, that's going to add up to 180 apparently, right? So, how do you go about this? Well, this is an algebra equation, and the smart thing to do when you're solving algebra equations is to simplify both sides. Now, 180 is just 180. That's as simple as it could get. Over here, you could add these two together in order to simplify the left side. Now, it is the case that 68 plus 54 is 122. Okay. And, all of this is still equal to 180. So just for my student watching, we did nothing more than adding the red 68 plus the green 54, and we got that 122. Hopefully, my student watching recognizes that m is clearly, the result of 180 minus that 122. Okay. So m is going to equal 58. Okay, because that's 180 minus 122. So that is how I would go about that one. That might be the hardest one because not only do you need to know, those two concepts that I had talked about before, you need to be familiar with both of these concepts, but also you need to kind of, spot what's going on over here and recognize that that's a linear pair, and you need to recognize that you could set up this equation and solve for y, you could set up this equation and solve for z. You really would benefit also from understanding that you could call this any letter that you want. Like before we knew it was a green 54, what did we do? We called it a green y. Right? We took initiative and called this y. Okay, here it is. I took initiative here and called that a red Z before I even knew it was 68, right? So that's kind of the purpose of algebra is you use these letters to represent unknown numbers, numbers that you don't know yet, right? And then you can set up these equations. So this was a relatively high level problem, okay? Anyway, for my student watching, hopefully that was helpful. For other people watching, hopefully that was helpful. And good luck, and I will talk to you later.